Well, good morning, everyone. This is our Vermil 47 coming to you from Dallas, Texas. Today is March the 7th, 2012. I'm making this video at 10:03 a.m. Central Standard Time. Well, I'm sure you know by now that the sun has really shown off, or has started really showing off for us for this cycle 24. We've had two X flares, one being the second largest in this 11-year period, come from this nasty sucker right here, 1429. It is not a happy camper, and it still has the potential to throw out some flares. It is a major sunspot. It's probably will be the most talked about, one of the most talked about in this solar cycle, because we've had such not really anything that impressive during this cycle. The cycle should be peaking probably early next year or sometime this year, and it's been very slow as it is, but it seems to be wanting to make up for it right now. Here's a look at one of the SDO animations from the Solar Dynamics Observatory, a 171 angstrom. Here's our big flare. To pop such a good flare on film, as we say, is really cool. If you just watch this, it amazes me is when it happens and right before it happens, you can see that the entire sun seems to just kind of change right up until it like pops right there. But you can see it pulls from other places. The magnetics get so twisted and so intense that finally something has got to let go. I mean, it's just intense. And again, a very intense solar flare this was. Now we've had much stronger solar flares, but this one happens to be intense, and it also happens to be pretty geo-effective, which means it's Earth directed. Anything it throws out is Earth directed, and I'll get to that here shortly. Here's the GO satellite X-ray flux. This would be the 3-day version. Here was our first X flare we had back on the 5th, and the coronal mass ejection from it reached us just a little before or right around the time that this started acting up, and we had our big X5.4, which caused a strong radio blackout, an R3 radio blackout. Strong, impulsive flare. This one was the more long duration, and that has more ejecta and more disturbance that comes out. This one is still going to disturb us. I mean, I'm going to show you something here in a bit, and it looks pretty amazing to me. It's the first time since we've had a new tool to look at that we get to see something this good. But anyway, here's how it's gone the last few days. It's kind of quieting down right now, but you just never know. Could that have been it's finally big wallop? Well, we could maybe only hope so, because in the next 2 or 3 days it'll continue to be geo-effective, and so anything that it throws out will be coming straight at the Earth. Now here's the satellite environment parameters. Again, I showed you this on yesterday's video, and it puts several of the parameters that we like to look at together. Lots of red here, huh? Decent geomagnetic storming. We've got a K index of 6 right now, and check out this is the magnetometer. As I tell you, when these incoming hit, it rings it like a bell, and it's still shaking. And we've had for 9 hours now, we've been above a K5 index, which is minor storming to moderate storming. This will continue. It may start to finally slow a little. It just depends on how much more the BZ component of the solar winds can stay, can try to start repairing our shields, as I call it, and keep our geomagnetic field from being so vibratory like this. Electron storm is continuing, but a lot of times when we start having stuff like this, it's hard. You can't trust this data. It's like if you looked at anything from the ACE satellite right now, where we get our solar wind speeds and our uh, density and temperature and all that, and the B components, you can't trust that because we're having a major, well, a moderate S3 solar radiation storm. If you remember me talking yesterday, I told you that the lower level protons or lower energetic protons had been up, but that if we had a big flare, we would see these streamers go up, and boy, they did. I just got lucky on that one. I had no idea that there was going to be such a strong flare. I knew there could be, but this is new science to most of us. We can't predict exactly when and how strong it'll be. I guess it's just kind of like the other love I have of just regular Earth weather. You just can't predict how strong and how bad a tornado is going to be and when it's going to happen. And these are just like space storms. But as you can see on this chart, it is it's an amazing storm. A lot of stuff coming together, and that sunspot meant business and still means business. We still need to keep our eyes on it. Okay, here's the solar wind forecast, and I show this to you on a regular basis, and it should be pretty obvious to you that when that flare happened, the coronal mass ejection blew out, bam. This happens to be Earth right here. What's it look like to you? Bam. And that bam is going to happen. This is a forecast now. On the sometime midday on the 8th, tomorrow, probably about, it could be tomorrow morning. This is a relatively fast moving CME. Now, it's amazing to me to see the wind speed, or the velocity of the coronal mass ejection itself, how fast the charged particles are moving. You can see white in there, and white is like up into the 800s and above, 900s. This graph here shows that at impact, it should bring us from 400 at least up to 800, if not 900 kilometers per second. That's an amazing jump. I can't really tell you what kind of geomagnetic storm that will cause, but I would expect to see on the 8th a major geomagnetic storm. I hope that all satellite operators, all energy grid operators are paying attention and adjusting wisely, and will be ready for this. I mean, if people know that work in those industries, but if you know somebody that works those industries and they're not kind of like, they don't keep up with stuff, or they don't care, this is gonna make a major impact on the Earth. Now, the big deal will be, will our BZ component, will our, as I call it, the shield, will our shields be up and strong? Even if they're up and strong, taking a hit like this is just going to be amazing. It's just, this is a classic, a textbook of a strong X flare and its ejecta, the coronal mass ejection coming out, and us being, I mean, we're not like directly, but it doesn't really matter. It's such a large coronal mass ejection that it didn't matter if we were on the upper edge or the lower edge. It's just going to hit us, and when it hits us, it's going to hit us hard. So again, right now, Aurora watchers are probably just all over the place. They're just enjoying themselves, and all I can say to you guys is, wherever you see auroras, you're going to really see them even brighter. I realize tomorrow there's going to be a full moon. I don't think that's going to stop you from being able to see the auroras pretty good. And remember, the best time to look for auroras, and if we get a big bad geomagnetic storm, we can see them far south. I wish I'd be able to see them here in Texas, but of course it's going to be raining. But hello, what am I trying to say? The best time to look for them is at local midnight. So that's when the sun is on the opposite, just almost near opposite side of the Earth from us. and that's going to be when it would be the darkest, and that's the best time to look for auroras. So again, this would be definitely an aurora alert. If you're on any of those services, I'm sure your phone's been going off. But anyway, in the middle of tomorrow, UT date 8, we're going to watch for impact, and it's going to be interesting. The only way we're going to be able to tell impact is I don't think we're going to be able to see it visibly on some of the monitors. We're going to have to look at some of the data that's coming in, and then we're going to have to like vet it and make sure it's good data, because with the proton storm going on, it's going to make it difficult. It's almost like it's how this may sound really freaky or stupid to people, but it's like the sun tries to blind us first just so we can't see what's coming, and then it shoots this out and it hits us, and we have no idea exactly when when and what time it hits. And I know that sounds like I'm getting on that paranoid stuff, and I'm not a paranoid or conspiracy theorist person. I enjoy listening to that stuff and watching it, because it kind of tells you the state of people's mind around the world. But again, I'm rambling here now, so I guess you can tell my state of mind is I've had a lot of coffee this morning. But this is going to be a good one, folks. Again, already you're seeing some major, with a KP index of 6 already, and the potential for it to make it to 7. And when this hits, some major storming is going to happen. Again, right now, I dare to forecast out, that we could get a KP of 8 or 9, or but I would say we'd probably easily get a KP of 8 when this hits. And again, that's going to be some major geomagnetic storming. I'll show you a quick look at one of the LASCO imageries aboard the SOHO spacecraft, and looks like somebody's got a scrub pad and scrubbed the lens of the camera, with all these scratches. It looks like scratches. Those are actually protons, or energetic particles, that are now bombarding the camera. This is why it's going to be difficult to see this next coming eruption as it gets closer to Earth. We've got much more cameras on our spacecraft than we did last go around, when we had a decent magnetic storm and solar eruption like this. So we should still be able to get an idea of when and what. But this shows the magnitude of the solar proton storm. In other words, this is radiation that's bombarding the Earth now, or bombarding the Earth's atmosphere. This is when they would start diverting planes from northern latitudes. They wouldn't be flying over the poles, because it'd be the equivalent to getting a chest X-ray from radiation, if not more. But and high latitude radio is probably just, well, it was knocked out for a while, because it was if I remember right, I didn't write that down, but I believe it was an R3. It made it to a radiation storm of 3, or a radio blackout of 3. So it had some pretty good noise with it. So radio blackouts, we get proton blackout, might as well call it that, because what can you say on here but just scattered stuff. And again, just think all that energy up there, all that energy is hitting the atmosphere, hitting the ionosphere. See how well our ionosphere can hold itself, and hopefully our shields stay up. One more quick look at another graph that I've left out the last couple of days, just because I just for some reason didn't put it on the video. This is the induction magnetometer from the HAARP research facility in Kekona, Alaska. This is very low frequency reactions in the ionosphere to things. These here are called PC1 pulsations, or PC3 pulsations, and they are generally just magnetic disturbances that are picked up, but in very low frequency. I believe now we're beginning to see our geomagnetic storm affect the ionosphere, because this is getting to be some broadband now, broadband reflectivity, or bright banding as I like to call it. in the vertical, and that will continue. In fact, it's getting saturated now down at the bottom. I mean, this is a very low frequency, ultra low. It's like almost 0 hertz, as you can see, but it's already getting good there. So we'll keep an eye on this. HAARP's fun to keep an eye on because it's kind of like our having a stethoscope stuck to the ionosphere, so we can see what's happening there. Well, I'm going to go ahead and leave you with this animation again from the SDO satellite. And just to recap, we did have an X-ray event that exceeded, of course, X1. It made it to X5.4, and that happened at right at the beginning of March 7th, the UT day March 7th. It happened at 2 seconds after the turn of the day. It lasted 40 minutes. That's a long time. We've seen them last longer. That's a long time. It created an R3 radio blackout. Currently we're having a geomagnetic storm, and a G2 level with our KP index is at 6. I expect that to stay there or go up. Solar radiation storm is at S3. It will continue to be up there, and it may begin to fall off, but it's going to be kind of hard to tell just when it will, just because, again, if we had that 40-minute flare, it had plenty of stuff to be thrown at us. And then as the big kahuna, the coronal mass ejection that's coming from this guy, will be here probably sometime during the midday on the UT day of the 8th, which is tomorrow, Thursday. Aurora watchers, this is your chance. Get out there. Look. I don't care how far south you are. When this coronal mass ejection hits the Earth, if you got clear skies, go out and check it out. We have weaknesses all over sometimes in the magnetosphere, and sometimes you just might get a shot to see some. And no, it's not going to hurt you. Just get out there and look at it. It's going to awe you, is what it's going to do. Anyway, that's it for now. Busy time on the sun. I like it. It keeps me interested in that. And I'll let you go with that. Again, this is R Vermil 47. That's a Robert Vermillion in Dallas, Texas. Y'all have a good one.